In this video, I'm going to show you how just about anybody can make use of machine learning to try to predict or forecast the future. So this is really cool. We'll get into it shortly. The first thing I want to warn you about though is this is not going to be a short video. And the reason for that is I'm going to be taking my time through every single step to intuitively first explain what's going on. I am not a math whiz. But the idea here is to help other non-math whizzes, if you are a math whiz, great, make use of this stuff. You literally don't have to look at any math in this video and you'll still know how to go and apply these techniques. So that's what we're going to go and talk about here. I will, of course, at some point be using the Crypto Wizards platform because this is literally what I built it for. But for those of you who are not on Crypto Wizards, I will be telling you, what machine learning algorithms you can use to apply the principles that you're learning here in this video. So, regardless, you should walk away with a lot of knowledge and you should be able to go and really do some very exciting stuff. So let's get into it. So the first thing very quickly is I just wanted to give some credit to Jacques Joubert. Jacques really helped me. He's my cousin. He's the co-founder of Hudson and Thames, and they do some very, very advanced stuff with machine learning in financial trading and other statistical methods for algorithmic trading. Jacques has worked with traders, he's worked at Shell, he's worked as a quant, super smart guy. And he also introduced me here to this person here, Marcos Lopez de Prado. I've never, I don't mean he introduced me in person, he made me aware that this person exists. I don't know Marcos, I've never spoken with him. I've been looking at some of the papers he's published. Jacques is writing or written an extremely good paper as well, which hopefully I'll get to share with you guys. But Marcos, some of the work that he's done here is, for me, really groundbreaking. It's opened up so many doors. And even yesterday, I built in some really advanced stuff into the platform that, deploys some of the concepts from this book. So it's really, really good stuff. I wanted to just, give credit to these two people because if it wasn't for them, I wouldn't be able to deliver any kind of quality to the degree that I'm hoping to deliver it to you here today. Okay, so let's start with you. This is you over here, right? So you have an idea. You are this person here and you want to try to forecast something. You want to predict, will the price of Bitcoin tomorrow go up? Or what will the price be? Or does the moving average crossover strategy work? Or using the sentiment data, can I, from Twitter or Reddit or whatever, can I predict what's going to happen with GameStop? Or will Manchester United beat Liverpool tomorrow based on the home team, the away team, all the player stats? These are problems you can solve with machine learning. And anybody can do this. And we've made it really easy to actually practically go and do it. But it's very important to understand the principles. It doesn't matter how you go about doing it. You need to understand the principles of what's going on. So here you have an idea, or you're like me, you have a plethora of ideas. In fact, your list just keeps getting longer and you can't execute them quick enough. You have a lot of ideas and you want to test them and you want to see, can I make a prediction? So that's a really powerful thing, right? If you can make a prediction, even with a 1% edge, and I think there's a video on the channel somewhere where I talk about the math around the probability you're going to lose money. And it's for me, it's the foundation of everything. So if you can get a 1% edge and you can become the casino, right? You can become the broker in a sense, and you can have an edge in trading, then you're already miles ahead of everyone else. Because, the material out there, particularly around financial trading, most of which is actually just garbage, right? If you actually go and scientifically test a lot of those strategies, and I don't mean back test them because that's also fraught with issues. But if you go and test those strategies, over time, most people will just lose their money. And there's lots of reasons for that. So the fact that you're even here, right? The fact that you're taking the time to intuitively understand what's going on here, even if you never place a trade or a bet again or ever in your life, you will understand why what you're going to learn here is far superior in many respects to some of the other techniques. Now, that's not to say that, for example, moving average crossovers don't work, etc. They might work depending on the strategy, what market regime you're in, etc. There's a lot of things that that have some kind of influence that you can actually learn about just by plugging in the data. So not only can machine learning, make these predictions, but it can even tell you what features it found most useful to make those predictions. So the first question is, what does a machine learning algorithm even do? Well, I can't really tell you in the sense that there are so many algorithms and many of them do many things, and they basically use a lot of mathematics to find relationships, and they put these relationships in what you call like higher feature spaces, higher dimensions, and then what they do is mathematically work out the relationships, etc., and try to make predictions from those. That's a disgusting explanation, and I know it is. And even though I've gone through a lot of machine learning courses and literature, etc., I don't really want to spend much time talking about how the algorithms work, because truthfully, if you're like me, like who cares, right? When you're just trying to do something here, high level, you want to plug and play, you want to experiment with an idea, you're not trying to super fine tune everything right now. I don't really want to go into the details of how machine learning works. Machine learning is huge. If I was to tell you how, for example, AI and deep learning work, that's a whole nother video. I'd be having to draw neural networks and put maths functions inside them and that kind of thing. So for this video here, what I'm going to do is I'm basically going to explain what it's doing with this pair of glasses. So here's your machine learning algorithm, right? And it's going to look at data, and it's going to take a subset of that data. So it's going to say, okay, I've got this amount of data here I'm going to use for learning, and then I'm going to carve out some other data which I'm going to test my learnings on. So I'm going to look at this, make some kind of assumptions, I'm going to find relationships, etc. And then once I have a set of rules, I'm going to apply these rules here to see how good I was. And then this is all part of the training cycle. And then finally it'll say, well, here's the best I got. Let me now, use this against test data that I haven't seen and see how good was I, in reality. So that's what a machine learning algorithm is doing. It's using all this advanced math to essentially work out what are the relationships and can I predict an outcome. Now, what I need to stipulate here is this is very broad the way I'm talking, right? I'm talking specifically about a subset of machine learning called supervised learning. And actually, I'm going to write that here because I think it's really important. So, when you're looking at machine learning, there's many different categories that you can be talking within. You can be talking about supervised machine learning, you can be talking about unsupervised machine learning, and you can be talking about reinforcement learning, which is also a lot of what is referred to as like AI. AI is, kind of an esoteric thing, if it even exists right now. But, that is machine learning. So there's many or three real subsets of machine learning. 99.9% of the time, to solve the kind of problem that we're going to solve here, we use supervised machine learning. And this means I'm giving the algorithm an output and telling it to try to predict and find relationships for that output. An unsupervised machine learning algorithm is mainly about finding relationships or finding, or basically giving an algorithm a bunch of data and saying, find what you can out of this. And, like, for example, there's something called principal component analysis, which is actually very useful in many ways. But it can take huge data sets and it can find relationships between data, etc., that you can then plug into a supervised machine learning model. But an example of unsupervised could be, I'm a company, here's everything about my customers, here's where they shop, where they eat, what they buy, how they dress, find the relationships between all of that for me, right? Supervised is like, hey, here's Bitcoin's price data. Can you tell me what the price tomorrow will be? Okay. Now that's, we're not going to be able to do that. Nobody can, right? To a degree. Nobody can predict the actual price of Bitcoin tomorrow. And sorry if you believe otherwise, punch it in the comments, that's fine. But we're going to be using supervised learning. I am very interested in reinforcement learning. I just don't know enough about coding it up myself to actually give you a decent demo on it right now. So here is a supervised machine learning data set, right? So we need to, if we go back down here, right, we need to give the machine learning algorithm the data. And so that's what this is all about here, right? We've got our data set here. And right now this could be, the stock price of Apple, right, for example, or Bitcoin or whatever. Let's call it Bitcoin for now. This is Bitcoin back in the day when most people could afford one Bitcoin. So here's Bitcoin's data. You have the open, the high, the low, and the close. And here's the first 7 rows of that data set. So this is from oldest to newest. This is the most recent time compared to time step number 1, which is the very first Bitcoin price ever recorded, right? And so we have the open, high, low, close price. This could be a data set with football teams, home team, away team. In fact, if you want me to do, I have been planning on doing this. If you want me to do a video on, using machine learning to bet football statistics and whether or not a team will win, maybe just punch football in the comments and then I know, right? I'll look out for those. If I see football, I will go and do a video actually using this with, betting data. So that could be really fun. But for now, let's use price data because this is what I spend most of my time with. So we've got the open, high, low, and close. Now, the first thing I want to say here is this type of time price data is actually not very useful in many ways. Usually what you want to do is convert your data into something called dollar bars. This is something I'm looking to build into the platform as well. But it depends again on the time frame you're looking at and the strategy you've got. But tick data or dollar bar data, etc., usually is going to be better than just standard price data. But for simplicity's sake, let's just continue with this because this is really, you can get a lot out of just this price data anyway. So I'm going to be showing you here in this video something really cool, and you're going to be so glad that you watched. I didn't mention it at the start of the video. This is kind of just a reward for those of you who are watching, right? I want to show you something that even this morning I just ran quickly on Bitcoin and I was like, wow, that's so cool. So I'm going to do that for you today as well. And you're going to be like, wow, this is mind-blowing. So, well, I hope so anyway. I found it mind-blowing. So here we've got our data. Now, the first thing you could say is I want to predict the close price itself, right? I'm here at day 7. I don't know what tomorrow is here on day 8. Here's all the historical prices. Can you tell me based on that what the price of Bitcoin will be tomorrow? So the answer is no. Now, the machine learning algorithm can do that. It can make a prediction and it can tell you on average how wrong it is. But the reality is that financial markets move in what's called a random walk. So they're usually very efficient. And so trying to predict the actual price it's almost impossible, basically. But there are some other things that you can predict. And, I'm going to show you an example of something which has some kind of predictable capability versus something that really doesn't. Now, somebody on the channel, had mentioned to me before they put in a comment, hey, why don't you just take well-known techniques and then put those into the machine learning algorithm? Absolutely. So you can make predictions based on, moving averages or MACD, etc. And I suggest to you that you experiment putting in sentiment data, etc. into your data set. And I'm going to show you how you can do all of this. But this is called feature engineering, right? Feature engineering is where you beef up your data. You try to put as many what you believe will be useful relationships or useful cause and effect features that will, have an effect on what's called the target that you're trying to predict. So for example, one example of that could be, volatility. So I could put in a volatility metric that shows, say, implied volatility or historical volatility, and whether it was low, medium, or high, right? Or a number. It could be an actual, volatility number. It could be in decimals. However you want to show that data, right? You create that feature. For simplicity's sake, I'm just showing you volatility as, an extra feature I can add in. So you could add in loads and loads and loads of different features, right? Sentiment, volatility, MACD, moving average crossovers, everything that you can think of. So the next question then becomes, well, if I've got all this data, how do I go and make a prediction? Well, it depends on what you want to predict. So if you want to predict the close price here of, say, Bitcoin, you could try to predict that. And that's then using what's called a regression model, right? So I'm going to just type regression here. And I'm also going to get a line here. And when it comes to, predicting financial markets, I'm going to put a line through regression. And the reason is because for me, it's not where all the sexy stuff is at. This is not, what we're going to use here is actually something called classification, which I'm going to talk about extensively in a moment. But regression is basically, it relates to predicting something which is continuous, right? So if I have the price of a house and I've got all the information about houses about houses in a neighborhood, and I want to predict based on that information for a new house what its price should be. That could be a really good regression problem. But we're not trying to predict the price here. We just want to predict, will, for example, the price tomorrow be up or down? Or will the price tomorrow again, will the volatility be higher or lower than a certain number, right? Or will it be higher or lower than it was yesterday? So these are really, the type of problems that you can solve, or the type of predictions you can make using supervised machine learning. And those are called classification algorithms. So I'm going to give you an example here now, and we're going to take this and I'm going to call this now classification. And we're going to add in what's called a target, right? So this is a classification type column here. This one here is regression. And in fact, I'm going to take this regression and I'm going to put it here. I'm going to put regression here, here, and here, because this is all price data, right? Volatility is a classification. Just for space, I'm going to remove this here. It's a classification type of feature, right? It's low, medium, high. It's discrete. It's not continuous. So this type of target, where I've got ones, twos, zeros, whatever it's going to be, is basically, this type of target is a classification target. And the target is basically a signal for what I want to predict. Okay, so here I'm going to say, okay, I've got volatility and I want to predict that. And I want to predict tomorrow's volatility, right? Is it going to be up or down versus today? Maybe that's what you want to predict. By the way, if you want to predict that, any machine learning algorithm in financial trading is good at predicting that. So it's not actually the most exciting thing to predict. What's more exciting is to say, is volatility going to be above or below a certain value based on, say, the average volatility? Or like there's things you can predict there where if you want to trade options, for example, now you have an edge. So we're going to talk more about that. I'm actually going to show you a specific real world example with Bitcoin here in this video. But for simplicity's sake, I just want to compare to the next day's volatility, right? So you can understand what's going on. So the target volatility is showing a 1. So low, for example, is a 0, medium's a 1, and high represents 2. So that's 1, that's 2, that's 1. So if you were to take something called low, medium, and high and put it into a number that a machine learning algorithm can predict, you would put low as 0, so you always start with 0, medium is 1, and high is 2. So you can see that 1 showed up here on the day before, 1 showed up here, 2 showed up here, 2 showed up here, 1 showed up here. So all this target column is doing is actually putting in what were the next day's results so that we can feed that into our machine learning algorithm over here. We can actually tell it what the next day was so it can try to predict that. So it can test, are there any relationships in all this other data that get me to that? And then eventually, you can give it your most recent data set here. And, it's a question mark. We don't know what tomorrow is, literally, because tomorrow hasn't happened, right? So today is the 17th of Feb. Tomorrow's the 18th. It would predict the 18th for me. No one knows what's going to happen. It's the future. Nobody can time travel to tomorrow and come back to tell us that. Unless you want to talk about general relativity, of which I've got can do a whole nother video on that. If you want to talk science ever, I love science, by the way, you can put relativity in the comments and I'll geek out. We can do something there, talking about quantum and special relativity and all that stuff. So you don't know what tomorrow is going to be, but the machine learning model is going to try to find out. And it's going to give you historically how well it would have done on data it's also never seen. So let's just take a moment here. Some of you are like miles ahead. You're like, yeah, I get it, just move on. And others are going, I don't quite understand. Like, how do you know what the future is? So for those people, let me just very quickly recap. This is a historical data set. So it has the following day in the data set. This could be, football results with who actually won, right? So the target is going to have historically what the event that actually took place that you're trying to predict. And in this case, we're trying to predict what is tomorrow's close going to be. Is it going to be up or down, or will the volatility, here we're trying to predict volatility, will it be up or down compared to today, right? Or will it be up or down compared to the previous day? You could come up with anything you want. And this we're going to feed into, the algorithm. So another example here could be the close price, right? If I look at the close price, tomorrow was up, so I put a 1. And then here, tomorrow was down, so I put a 0. And then the next day was up, so I put a 1. The next day was up, so I put a 1. The next day was down. You can see here it went from 610 to 575, so I put a 0. Now, this is important because there is a difference between this type of classification and this type of classification. The type of classification here with a close price where you only have a 0 or a 1, true or false, 0 or 1, yes or no, happens to be my absolute favorite. Always, when I'm running a machine learning trial in, financial trading, etc., I am doing the 0 or 1. And this is called a binary classification problem, right? Or target that we're trying to solve. And the reason why binary classification is so useful is you're going to see it gives us a whole bunch of metrics that help us to understand relationships and make predictions so much better than, I'd say so much better. That's not true. But for me, when it comes to trading, for me, I'm just like, is it going to be up or down? Yes or no? Is it good or bad, right? Everything is coming down to a decision, buy or don't buy. And so I really like binary classification, right? I love that kind of thing. If you're predicting football results, is it going to be home, away, or a draw? Is it going to be the home team that wins, the away team that wins, or is it going to be a draw between the two? Then this is, your standard classification where you've got like 3 different outcomes that can happen. Here, we're going to be focused mainly here on binary classification, but, the principles still apply as you move on from there. So again, now hopefully going back to your idea you had earlier, and I know you've got ideas if you're watching this video, your brain's probably thinking, what could I predict? What do I believe in? Truthfully, you probably have something interesting there that you could test out. Hopefully now you understand, okay, I could put this data in and then tell it, the target of this that I wanted to predict. If you have that understanding, then you're doing really well. Then basically you've got it, and the rest of this is now just academic. So let's just go up here, because now we need to actually give our machine learning model data. So if I go down here, here's my data. I need to give it that data. So how do we structure the data? So I've got my data here, I've added in volatility, I've done some feature engineering, I've added in my targets. But now, how do I structure my data? Because I need to split it. And the reason for that is you don't want to give a machine learning algorithm all of your data to train on, right? And the reason for that is because it's going to be using what actually happened in its algorithms. Therefore, when it makes predictions, it already kind of knows what's happened because it trained on that data. So what you want to do is you want to be kind of mean to your machine learning algorithm in a way. You want to hide some things from it. Okay, so what we're going to do here is we're going to say, look, this portion of the data set here, let's call it, 70% of this data we're going to be using for training. And so what that means is this part is really here for this machine learning algorithm to look and find the relationships, right? And so that's what we're going to do. We're going to carve up the data set to do that. Now, there's really 2 kind of ways you can think about carving up your data set that I'm aware of. The first way is going to be based on time series. So, when you're trying to predict what the price of Bitcoin, for example, will do, you're looking at a time series data set, right? You've got all the days in a row of what's happened. That's what we're trying to do. We're trying to, do time series. And so usually what you're going to do is if this is, day 0 and this is today, right? You're going to want to carve up your time series data from the first part of the data starting from 0 to whatever that 70% day is. Call this day 1000, right? You're going to want to carve your data up like that. And the reason for that is because you don't want to mix in future days that you want to use for testing. So basically what I'm saying is you want to try to get results on how it would have performed on a recent time frame on data that it's never seen. And that's what I'm trying to say. So I'm just doing a very bad job of explaining that. And then so, a more mixed approach. So if I take, something like this here, I could say, let's take a mixed approach, and I'm going to make this green as well, and say, okay, I'm going to carve that amount and that amount and this amount. And, I'm just going to take random chunks of data, and I'm going to, include it as the training, and the rest of it I'm going to include in testing, etc. So you can do that. That's called mixed. And if I was predicting something like football results, for example, I would choose mixed, right? If it's not time series in that sense, in the sense that, we're talking about Bitcoin, 99% of the time you're going to be, shuffling your data. So here we go. So we've got that here, we've got our training set, and then here I've got my test set here, right? So the test set is now the machine learning model is going to take everything it learned, and it's going to give you its results. It's going to say, right, I'm going to apply everything I learned, and I'm going to apply it to data I've never seen. I did not learn with this data. And here's the results, right? So it's going to give you those results. And then one other thing I like to do is I exclude another, say, 10% of the data completely, purely for reporting. So this is going to be data that, again, it's absolutely never seen before. But it's going to make predictions, and it's for more recent data. You don't have to do this. I just like to do it because I like to report out what will tomorrow be. What is your answer? And so even if you have like 10 rows of data here, it's absolutely fine. But I like to, again, run the machine learning model again through another subsequent data set to see most recently, how did it do? This is more of a Seanism. This is not something I've seen done much. Maybe it is, maybe it's done a lot. A lot of the stuff I kind of learned just by testing and seeing, what gets me the best results. So this is how you split your data. Now, for those of you who are coding in Python, the easiest way to split your data is called train test split. That will shuffle your data for you. And then you can just Google how to code up, splitting data by time series. For those of you who don't know coding and don't want to bother having to learn to code all of this, that's obviously what Crypto Wizards is for, right? So, well, it's for two things. Crypto Wizards I built because I wanted to test things from my mobile phone in bed whilst I thought of an idea without having to code. And it's also for speed. It's just very, very quick. You can come up with an idea which is completely fresh and within 5 minutes know whether it'll work or not. So, so you don't have to know coding to do this. But for those of you who are not on the platform, who do know coding, who do know Python, scikit-learn, train test split, you can Google it. There's so many blogs on how to split your data up. Cool. So now we give our data to the machine learning model, right? And so it's going to do this training and testing element here. And it's essentially going to go and learn. And if you put in reporting, it's going to go and report out as well. And this is what it comes up with, right? So it goes through all of those mathematical predictions, and it comes up with a data set. And actually one of the things that also would have had in here, sorry, I should have put in from earlier, is our volatility, right? So it's going to have this volatility column as well that we showed earlier. It's just when I drew this up earlier, I didn't add it in. So it'll have all your features, right, that you put in. It can see all of those, and then it's going to say, okay, here's what your target was for, the close price or the volatility or whatever your target was, but here's what I actually predicted. And so here you can see this was true positive. So this one and this one were identical. It got it right, tick. And in fact, we're actually going to go down here and we're going to tick these as we see they're right. So that one was a tick, that one was a tick, that one was a tick, and that one was a tick. Now, the one I haven't ticked here was incorrect, right? Actually, let's do that here in red. The one I haven't ticked here, that's incorrect. And it got this one wrong, okay? And the reason is it didn't know, right? It had never seen, it had never actually seen this, because this is the reporting data or the test data it was given, right? It didn't see this target, right? When it's going through actually learning here, when you give it this data, you're telling it what the target variable is. It doesn't see that, right? When it comes to testing, it doesn't see that target variable. Here in the training, it does, because it's using that to figure out what's going on. But here on the data, in terms of the test or the reporting data that we're looking at, it hasn't seen that target variable. So here it knows, here it's giving you the data back that it never looked at for making predictions. So, here it used all this data here to make predictions. So that it used, that it didn't. So this is very important, and probably I should have slowed down there. But it's using this data, the features you gave it, to predict the target. The target it never used, it never saw. And so it's giving you back the predictions. And it's saying, okay, here's the target I never looked at. Here's how it did compared to that. And it's saying here, you didn't get this one right. And so this is where it becomes very useful, because now, let's say here, it's giving me a prediction of 1, right? That is what it's saying tomorrow is going to be. It's giving me the next day's prediction, right? It's telling me tomorrow is going to do this. And not only that, but it can even tell you how confident it is. So there's something here, and I'm going to show you in the real world example, where it also adds in a probability column that tells you it's not the probability, but its probability of how confident it is on that result of what is going to happen tomorrow, or whether that team is going to win, or whether you're going to eat a hot dog, or whether someone has Ebola, whatever it is you're trying to predict. That's what this column here is doing. And this column is the value of the whole process. This here is what makes this all amazing, is it's actually giving you the result of what it thinks it's going to do and how confident it is. Now, the next question from you should likely or logically be, well, how do I know I can trust that, right? And just looking at this data, you'd say, oh, okay, it gets most of them right, so probably it's correct, right? Broadly, that could be a way of doing it, but there's a much better way of looking at how good and how accurate is this model, and that's what we're going to look at over here. So this is called a confusion matrix. Let me actually go and grab a title here, because I think we're going to want to title that. Who knows? Maybe I'll use this one day in a course or whatever. But here this is called a confusion matrix, like this. And it's not because it's supposed to be confusing, but the confusion matrix is one of the most useful things ever, because what it does is it tells you, based on what actually happened in reality versus what the model predicted, how good the model is. And it will tell you how many of everything it got right or wrong. So let's go through each box here to actually explain what's going on. So the top section here, and it depends on what site you're using or what algorithm you're using, is usually the actual, what actually happened. And the left-hand side here is predicted. What did your model predict would happen? So you can see with the actual, I've got the 0 and I've got the 1. The 1 being, will it be up? The 0 will, will it be below or down on the previous day or the current day? So that's what the actual is happening. So it's saying, okay, where everything was actually a 1, out of the whole data set, I got 40 of them right. And, in terms of, I predicted a 0 when it was actually a 1 20 times. Okay, so let's look at this a few different ways. So where it was a 1, where it was up, and I said it should be a 1, I got that right 40 times. In other words, we nailed it. Where it was a 0, and I said it would be a 0, in other words, the model said it would be a 0, we got that right 30 times. So that's called a true negative, right? It's a 0, so it's true negative, and a 1 is positive. It's a true positive. You want to get as many of these and as many of these right as possible. And if this is a signal to go long, then you don't really care so much about anything other than, because you're trading, you don't want to lose money, getting them right. You want to get as many trades right as possible. So you want to predict as many true positives as possible, essentially. So really, then the most important metric from a trading perspective, and depending on the problem that you're predicting, there's different metrics that are going to be useful. Excuse me. But the most important metric here is going to be called what's called the precision. And so what the precision is doing is it's saying, okay, let's take a look here. Let's say out of everything you predicted, which is this here, how many as a percentage did you get right? Okay. So here I got 40 out of 50 right? I got 4/5 right. That's essentially what this is saying here. You want this number to be as low as possible, because in trading, And this is, it was great because when Jacques was pointing this out to me, I was like, yeah, it makes so much sense. I've been on the platform, I've been calling this the win rate, right? Precision is basically your win rate, right? Saying out of all the trading decisions I made, out of all the bets I made, how many of them did I get right? Now, the reason why you want this number to be low is these 10 mean you lost money, right? You want this to be 0. You don't care if all the other stuff is high. Doesn't really matter, right? Your model accuracy can be really bad. If your precision accuracy is great for trading, who cares, right? You're not losing money in that scenario. So, be very careful when you're looking at accuracy, and I'm going to show you some real metrics. When you're looking at accuracy, be very careful because accuracy can be very misleading, right? You need to know what accuracy you're looking for. And usually with financial data, it's the precision. Because anything that was a false positive, i.e. I thought it was a 1, so I went to place the trade, but it actually wasn't, I lost money in. These 2 boxes here, if I was shorting here, I made money. If I was going long here, I made money. These 2 boxes here, not so much, right? This one in particular, this one here, the predicted, but I got it wrong. This is a bad guy right here. Now, the recall is basically out of all the possible opportunities I could have got right. So that's this here, right? Out of all the possible opportunities I could have got right, how many did I get right? So here it was basically 4/6 or 3, what is that? 2/3. Is that right? Yeah, 2/3 or whatever. No, that's wrong. My fractions, you can tell I'm bad at math. But here we go. So you can see that, there were a whole bunch of trades that I never decided to place that I could have, which were a long, right? These are how many longs, how many going long did I miss? If this was football, would a team win or lose? How many times did a team win that I didn't bet on, right? So that's what the recall looks at. And there's a really cool curve. In fact, we have it at Crypto Wizards. It's called a recall precision curve. And it looks something like this, right? It'll basically tell you if this is my precision going up to 1, and this is my recall going up to 1, how precise was my model? So what you'll typically find is as the amount of recall increases, my precision gets lower. And so what that means is typically being highly selective is the strategy, right? You want your model to be as highly selective as possible. And this depends on the machine learning problem, right? If you're trying to predict a pandemic, for example, you're going to look at this a very different way. So I've just cleaned this up a bit because it's getting quite noisy here. So, we were talking about the RPC curve, but let's talk about the ROC curve. So there's another curve. It's called the ROC curve. And I believe that stands for Receiver Operating Characteristic. Could have got that wrong. But the ROC curve essentially looks something like this, right? You've got your true positives as a rate. So that's like looking at your true positives divided by kind of the total, I believe, of the true positives and the false negatives, I think. Don't quote me on that. Maybe look it up. True positive rate, and then you've got the false positive rate. And that's sort of your false positives over here. So as your false positive rate approaches 1 and your true positive rate approaches 1, both starting at 0. If you were a monkey with a machine gun, right? So if you basically had complete random, the chart would look like this, right? It would look like this. This is basically no skill is involved whatsoever, right? That's what a ROC curve would look like. You would just have a line that goes straight like this, which we call like the no skill line, right? But if your model's any good, it'll basically look like this. It'll have a curve. This is like a really good model. This is like perfect, right? Typically what you'll see is different models will perform differently, right? So you might have a model that sort of looks more like that. And the more to the left and up your model is above this, call it the monkey with the machine gun line, the better your model is performing on the whole, right? So this is saying, look, your true positive rate stays high. Basically, that's it. You're getting, these are looking really good. And this area under here is called the area under the curve, right? So I'm doing rubbish at this bit here. I know I need to spend more time with curves, but it's fine. This area under the curve is essentially the entire area that curve takes up, right? So you can imagine that the more area under the curve, the better your model's performing. And that area under the curve is called the AUC. And so, for example, an AUC of 0.8, is better than an AUC of 0.7, right? So typically that's what you're using the curves for as well. Now, I'm making a lot of mess here. I think it's time we actually get practical and, we go in, start actually running real data and looking at, percentage accuracy and precision, etc., and comparing it in different data sets. And it actually, when you're doing this stuff for real and you're not like showing it, it's very quick. But again, I'm going to go through everything. I'm actually going to cut this video here. This can be part 1. I'll release part 1 and part 2 at the same time. So that's for those of you who are watching and want to continue, you've got that other video in. But for those of you who kind of wanted intuition separated from the main video, then you've got that as well. So I'm going to go and do that now, and I'll see you over in the next one shortly.